Hey everyone, in this video we're going to be learning about quadratic equations. The quadratic equation is easily one of the most, if not the most important equations that has ever come out of mathematics as a field, having applications in a myriad of fields, such as physics, engineering, architecture, and much more. In this lesson, we'll be covering the various ways in which you can solve a quadratic equation and also do some practice problems so that you can get a hang of the process and also see how it can be used in everyday scenarios. But before we open up this can of worms, let's begin by figuring out what a quadratic equation actually is. Quadratic equations often come in one of the following two forms, known as the standard form and the vertex form. There are two features shared between both forms that make both equations quadratic equations. Number 1, the degree, or the exponent of the leading term, of the expression is 2, and the fact that they are both equal to something. In the case of quadratic equations, we always want to make sure that they are equal to 0, as that is when we can actually go about solving them. With all that said and done, we can finally move on to the first method, solving by isolation. This is a method that most of you are probably the most familiar with, since all it involves is some basic algebra. It works best for equations that are in vertex form. To get a better understanding of this method, let's do a problem together. Now we can move on to our second method, factoring. This one might be a little less familiar to you guys and is a little less straightforward, but you'll get the hang of it with more practice. This method is pretty much exclusively used for equations in standard form, and is quite efficient if done properly. Now, there are many ways in which one can go about factoring, but the one I'm going to be showing you is a method called factoring by decomposition, where we essentially break the quadratic equation apart to figure out what its factors are. For the sake of comprehension, let's try yet another practice problem. Take the equation 0 equals x squared plus 3x plus 2. The first thing you want to do is multiply the coefficient of the leading term by the constant term, which in this case will result in a product of 2. The second is that you want to split the x term such that the coefficients multiply into the product that we have just found, but also add up to the x term in the equation. For this example, that will be 2x and x, because the coefficient multiply into 2, and they both add up to 3x. After that, we essentially have two binomials, to which we can factor out a common value, such that the expressions in the parentheses are the same, as shown. In our case, this expression is x plus 2, which we can then factor out to get x plus 1 times x plus 2. Finally, we can set both expressions equal to 0, allowing us to find out that x equals -1 or -2. Now for our third and final method, the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient of the leading term, b is the coefficient of the second term, and c is the constant. This is the most difficult method out of the three, but it can be applied in all cases assuming that the equation is in standard form. That said, I would only advise using it as a last resort if the other two do not work out for you. I'm sure to a lot of you this method may look a little intimidating, but in order to stop being scared of something, we gotta face it head on. As such, let's do a practice problem to properly ingrain this method into our minds. Let's take the equation 0 equals x squared plus 5x plus 6. The first thing we have to do is plug in the coefficient values of our equation into the quadratic formula, and then multiply and evaluate whatever is in the radical so that we get x equals -5 plus or minus the square root of 25 minus 24 all over 2. Then we can subtract 24 from 25 to get the square root of 1, which is just 1. This then leaves us with the equation of x equals -5 plus or minus 1 over 2, which we can then evaluate when 1 is both positive and negative to figure that x is equal to either -2 or -3. Now that you've learned all of the methods to solve a quadratic equation, let's do one final practice problem to show you how this concept can be used in real-life situations. Let's say that you were in charge of building a rectangular backyard with 18 meters of fencing and an area of 20 square meters, and you want to know what the length and width of your enclosure should be in order to accomplish that goal. To solve this problem, all you will need is two basic geometric equations, which I'm sure you're all familiar with. The area of a rectangle is equal to its length times its width, and the perimeter of a rectangle is equal to twice the sum of its length and width. I would encourage you to pause the video and try to solve this yourself before we get on with the solution. Now that you have hopefully attempted this problem, let's go over how you can actually solve this thing. Let's start off with the perimeter formula, P equals 2 times L plus W, where L equals the length and W equals the width, and plug in the value of our perimeter to get 18 equals 2 times L plus W. Then divide both sides by 2 to arrive at 9 equals L plus W, and then subtract the width from both sides so that we finally have 9 minus W equals L. Then we can switch our focus over to the area formula, which is A equals length times width, and plug in 9 minus W in for L and 20 for A to get the equation 20 equals 9 minus W all times W. Expanding this out and subtracting 20 from both sides, we get 0 equals negative 20 plus 9W minus W squared. Dividing both sides by negative 1 and rearranging such that the W squared is in front, we get that 0 equals W squared minus 9W plus 20, which is a quadratic equation in standard form. At this point, we can either use the quadratic formula or factoring to solve. However, I would try first to check if the latter works before trying the former, and as it turns out, the equation is perfectly factorable. If we apply the method we learned earlier, the leading coefficient and constant term multiply to get 20. Now we look at the negative 9W term to see how we can split it such that the coefficients of both terms multiply into 20 and add up to negative 9. In this case, this will be negative 5W and negative 4W. Once we have split up the term, we can factor out values from both binomials such that the expression in the parentheses is W minus 5. Factoring out the W minus 5, we get the final equation of 0 equals brackets W minus 5 times brackets W minus 4. And we can figure out that the width is either 5 meters or 4 meters. Plugging in these values back into the 9 equals L plus W, we get that the length of the enclosure is either 5 square meters or 4 square meters. So the dimensions of the fence that you would have to build would have to be 5 by 4 meters or 4 by 5 meters. Thank you all for watching. I hope this video helped you in some sort of way. Always remember to never stop learning, and I'll see y'all in the next one.